So what we're working on right now is SB 13. This is the explanation video for all the geometry. Remember, on Friday, you'll have 10 questions on a quiz over this. This is pretty much circles and a few other shapes on this today. So remember, the first few pages are all explanations that you should take time to read through. It's kind of your little notes or textbook. There's some good stuff in here. But to save time, because you don't need me to read for you, here's a bunch of formulas on the last page. So kind of keep an eye on that. We're going to work the 20 questions here on the orientation and practice exercises together. So let's start here on the orientation exercises. Following are the distances in feet of 5 points from the center of a circle. So you got your center of your circle. You got your 5 points around on the side. They're all around there. If the diameter that's across the circle is 6 feet, what point lies outside the circle? Okay, so we're saying if the diameter that's all the way across the circle, that's your diameter, and then all of these points are just on the outer edges, so we'd call that the radius. That's like half that diameter. So they need to be within 3 feet, because 6 divided by 2 is 3 feet. So let's see which of these numbers is bigger than 3 feet. Well, that would be point S. So our answer, the only one that's bigger than 3 feet, which is point S here, is B. That's an easy question. Okay, number 2. When the circumference of a circle is increased from 10 pi inches to 15 pi inches, by how many inches is the radius increased? Well, this one you need to know a little bit of information. So I'll get this little text box. Actually, I need an equation because I need the pi symbol. This says circumference. So we know the circumference formula is 2 times pi. So let's go find the pi sign. Let's move my picture out of the way so I can see better. There's the pi sign. Let's go back in the little thing, type pi, and then r. 2 pi r is the circumference of a circle. So 2 times pi times the radius. All right, so it started out, put me another little text or equation box, that it started out at 10 pi. Okay, so I'm going to go to pi for the circumference, and that's equal to 2 times pi times r. All right, so if it's 10 pi for the first circumference, and that's equal to 2 times pi times r, if I divide both sides by 2 and pi, 10 divided by 2 is 5. That tells me that r is 5. That's how big the radius is in the beginning. Now we're increasing the radius. So the radius is now 15 pi, and 15 pi is 2 times pi times r. And I'm going to divide both sides by 2 and pi. So 15 divided by 2 is 7.5. The radius is now 7.5. So it went from 5 to 7.5. How many inches bigger did it go? Well, 7.5 minus 5 is 2.5. So our answer to this question is E, 2.5. Does not want to, there it goes. All right, number 3. In the figure, angle AOC is 48 degrees. All right, so this guy here is 48 degrees. And we want to find angle ABC. That's the guy up there. All right, so one thing that I know is that's a central angle. And this is his little arc right here that he cuts. They call that word subtends. from A to C, this angle has this arc. But look here, this angle here also has the same arc. So that means they have the same degrees. They're the same size. So C, he's 48 degrees also. It's a cool thing. That was pretty easy. All right, number 4. Now we've got this picture. O is the center of the circle. RST down here is 30 degrees. So this guy is 30 degrees. And TW is tangent to the circle at T. That means he's a right angle, by the way, guys. When you have a tangent to the circle, it is a right angle. And we want to know the measure of TWO. Okay. Well, we know this guy down here is 30. Let's see what else we know. We know that this side right here and this side right here and even this guy and are all the same length because they're all a radius. So if they're a radius, we know that this guy and this guy are the same length. This one's 30 also, because that's an isosceles triangle. So we're going to put a 30 on him. Right there. That little angle is 30 in here. So we know that much. Well, opposite that is the angle. Opposite him is, we're getting the same kind of sizes here. And so I can verify that this guy, there's 180 degrees in a triangle. So I'm going to go over here and I'm going to say there's 180 degrees in a triangle. Minus the two 30s that I have. 180 minus the two 30s is 120 degrees. So that means this piece right up here where the O is, I'm going to draw a picture of him. I'll make him blue so he'll be easier for you to see. There we go. So this blue angle is 120 degrees. Well, next to him, that makes a straight line. So I'm going to make a text box. There's 180 degrees on a straight line, and this guy's 120 degrees, so his buddy must be 60. I'm going to make him green so you'll be able to see him. I'm going to find the colors again. Come on, colors, pop up. Okay, so this one is 60. That's the green one. That's 60. All right, I still want to find this guy in the corner. Well, 60, 90, and something, they have to add up to 180 degrees. So I'm going to figure out what that number is. 180 degrees minus the 90 in the corner minus the 60 that's green leaves me 30 degrees for the red angle on top. So my answer is 30 degrees. All right, number 5. In the figure, we're going to find the area in square meters of the entire region formed by the triangle and the semicircles. That's the whole picture. We want his area. Now, how are we going to do that? Well, we're going to use some things that we already know, like the Pythagorean theorem. Over here is a right triangle, and we know the Pythagorean theorem. We know 2 squared, that's a squared, plus 2 squared, that's the other side, b squared, equals c squared. We know that. So, we know 4 plus 4 equals 8. So, c must be the square root of 8. So I'm going to put square root of 8. Okay, so that one means that this guy here is square root of 8 long. This entire A to B, okay, because he's the hypotenuse of the triangle. If he's square root of 8, I guess I could undo that and just kind of write, just to let you know that that's A to B is how big square root of 8. Now, I want to half that. Why do I want to half that? Because I have a circle over there. Well, half a circle. And I'm going to need pi r squared. In other words, r, I need a radius. So, the square root of 8 divided by 2. And I'm going to rewrite this square root of 8 as 2 times the square root of 2, because that's what he breaks down into. And I want to divide that by 2. Well, that means that these guys will cancel, and that means that the radius is square root of 2 long. So that piece is square root of 2. That's the radius of the circle. Now, that's the first part I need. I need to know how big the circle is, which is an area of a circle, and then I have to find the area of the triangle. So I'm going to do that part over here. I'm going to do the area of the triangle plus the area of the half circle. Okay? And here's where I'm going to start typing. So area of a triangle, we know that formula is 1/2 base times height plus our area of our triangle. Since it's a circle, it's a semicircle, so 1/2. And yep, I should have used the equation because I need a pi. Go back to that. Area of our triangle is 1/2 base times height plus the half a circle, so 1/2 times pi r squared. So 1/2 of a circle's area. That's what I just wrote. Move that over, you can see better. Now I'm going to have to plug in for all of those numbers. So area is 1/2. The base of the triangle is 2, and the height is 2. So 1/2 times 2 times 2 again, plus 1/2 on the circle, pi. And then we found the radius here. The radius of the circle is square root of 2. So parentheses, and inside I want the square root of 2. And then I want to square that because it's pi r squared. And I'm going to move this where you can see it just a little better. Now I'm just going to simplify all of those numbers. So area is 1/2 times 2 times 2. 2 times 2 is 4 times 1/2 is 2 plus square root of 2 squared. Remember exponents first. That's 2. 2 times 1/2 is 1. So it's just a pi right here. So I'm going to get the pi sign. So my answer is 2 plus pi. All that work, and that's what my answer is. And what did he end up being? A. All right, trucking on along, number 6. Find the area of a sector of a circle if the sector has a central angle of 90 and a radius of 2. All right, so here's how that one goes. We have a formula for it, of course. Area of a sector. So area of a sector is 1/2 times your angle, and we usually call that theta. I don't know if you've learned that. It's a circle with a line through it, times r squared. And so these are some things that you may or may not have learned. Actually, you probably learned this instead of theta. I think you probably learned it as n over 180. Yeah, I think that's what you did. I think you guys learned it as n over 180. N being, well, that didn't work like I wanted it. So I just want the n to be divided. No, the n divided by 180. That converts your angle from degrees to what we call a number in radians. I know that's a word you probably don't know yet, but that was probably the formula you were given. in geometry. So area equals a half. N is going to be your angle, which is 90 degrees. So now I'm going to take it times 90 over 180 times, and now it says R for our radius, and it tells us the radius is 2. So 2 squared, because it says radius squared. Now all you're going to do is just type all those numbers in the calculator. 90 over 180 is a half. Oh, I forgot one little thing. That guy should have right here a pi, and go back to this equation. Like I said, I don't ever use this equation since I did trig, but it's one that you guys will need to know here. So I'm going to use the one that you're most familiar with. All right, now I'm going to go back down here and figure this guy out with a little bit of math. So I go to my calculator. Area is a half times 90 over 180 is another half. That's a fourth. And 2 squared is 4 times the pi in there. So that's basically 1 times pi, which is pi. So you can do all that math to find out your answer is just simply pi to this problem. The area of a sector formula, I'm sorry, like I said, I used to changing it from degrees into radians kind of thing. It's your central angle, which was 90 degrees. That's your angle. That's what we call N. Right there. Times pi over 180 times your radius squared times a half. So, sorry about that. It was not a very good explanation there in the beginning. All right, now we're going to move on to number 7. This one says, in our figure, angle PQR, which is labeled, is inscribed. That means he's inside your circle, and he's like his vertex is on your circle, and his little ends at the end are also on the circle. So he's like stuck inside, inscribed. And it says, we want to find the measure of arc, PR. Well, since he's an inscribed angle, that's the key word that they gave us, inscribed, then that means this arc, or this angle, if you multiply the inscribed angle times 2, it'll give you the arc. Well, 30 times 2 is 60. So that arc is 60 degrees. That's as simple as he is. So there he is. That's how you find an inscribed angle and his arc. The diameter of a circle with an area of 225 is what? Well, here's things that we know. We know the area of a circle is pi r squared. And according to what we just did, I'm going to move this out of the way so you can see it better. It says the area of this circle is 225 pi. 225 pi. And that equals the area of a circle formula is pi r squared. Now I'm going to solve for r. So if I divide by pi on both sides, I get 225 equals r squared. So if I divide by pi on both sides, the pi's go away. And then I want to take the square root of that. So the square root of 225 says r is 15. So that's the radius. But it says it wants the diameter all the way across the circle. The radius is halfway, so I multiply this times 2 equals 30 for the diameter. Here he is. All right, number 9. That's one of those things that the elephant stands on. It's got the 4 sides. It's a trapezoid. And he has bases that are 14. Oh, it might help if I turn a little thing on here to draw. His bases are 14 and 6. And he has an area of 120. And they want his altitude. Altitude is the height in here. So they want to know how tall that is. All right, back to our formulas. area is the height divided by 2 times the two bases, base 1 plus base 2 added. That's our formula for the area of a trapezoid. Now our trapezoid is 120 for the area. We don't know h, so h over 2. But we do know the two bases. One of them is 14 plus the other one is 6. So I get 120 equals h over 2 times 14 and 6 make 20. So I get 120 equals h over 2 times 20. 20 divided by 2 is 10. So 10h. Divide both sides by 10. I get h is 12. So my answer to this one is 12. And number 10. The circumference of a circle, that's around the outside edge, who has a diameter across of 25. That's an easy formula. Circumference is pi times the diameter. It's also 2 times pi times r, because diameter is 2r. Well, let's put in what we know. Go back over here. Circumference, that's what we're trying to find, is pi. All right, let's go back over there and put the pi symbol in. Times the diameter. The diameter is 25. So our circumference is 25 pi, which is D. All right, we made it through the first 10. 10 more questions to go on the practice exercises. I hope some of this is coming back to you. All right, question 1. We've got a diagram with a line segment, and we want to know which one of those is the diameter. Well, diameter goes all the way through the center across the circle. So going through O, the only person that goes through O is DG. It's an easy question. Hope they give us more of them. If a radius of a circle is doubled, what happens to the circumference of the new circle? Well, it's going to be doubled. Now, how did I know this? There was a trick back in tax days. You remember the tax test? Way long time ago. It's when I first started teaching. And these were some of the questions we asked in Algebra 1 was about these doubling, tripling, and those kinds of ideas. How does each of these things affect them? So radius. Radius is a length, like you can measure it with the ruler. Circumference, it goes around the circle, same idea. Those are going to be like in feet or centimeters or inches or something, but it's not like inches squared or centimeters cubed. It's singular. Centimeters, inches, feet. So whatever that thing is being done, which is in this case doubling, it's going to be the same for the other one because they're in the same dimensions. So double and double. Now, what point am I getting at? Well, if it was talking about if the radius is doubled, what happens to the area? Remember, areas like pi r squared, it's got squareds in it, centimeters squared, feet squared, inches squared. It's got the little 2 up there. It would be doubled squared. So it'd be 4 times bigger. 2 to the 2 is 4. So my answer down here would be like 4 if it was area. Now, if it was volume, that's length, width, height, like a cube. Those are usually like cubic centimeters, cubic feet, cubic, they have a little 3 on them. So if it was doubling, but volume, it'd be doubling, but volume 3, 2 to the 3. 2 times 2 times 2, 3 times is 8. So it'd be like 8 times bigger for the answer. So I was kind of giving you a little idea because I know it's been a long time since I've seen problems like that. It was tax kind of problems, but those might pop up every once in a while for you because, you took geometry. So that's how I knew on number 2 it was C because they're in the same dimension, the first one. All right, number 3. in the figure below, X, Y, Z is inscribed. So remember, he's inscribed. His little butt or vertex is sitting over here. His little legs are over there. He's good. And XZ, that's the arc, is 60 degrees. What's the measure of XYZ? So we're going backwards. Well, to go the other a moment ago, we went angle times 2 equals arc. So I'm going to go backwards, and I'm going to divide by 2. 60 divided by 2, and that will give me angle. And we know 60 divided by 2 is 30. Yay! All right, number 4. O is the center of the circle. AB is parallel, well, that's not a little drawing line, to CD. So these are parallel lines. And they say, find the measure of angle Y. Okay, I can do that. So what kind of things do I know? Well, I know that this arc right here is 70. Right? I know that. So, and this here is X, and this is X. And I'm looking at this from here. This is like a 180 degree arc. Has to be, because it's half of a circle. So, if I know that guy is a 180 degree arc, I'm going to go over here to the side. The entire half of a circle from C all the way to D is 180 degrees. I'm going to take my 70 degrees away. That leaves me 110 degrees to play with. But that's this little part here, and I'm going to put them in blue so you can see them better. So this little part here, well, not a very good drawer, and this little part here, those two arcs add up to 110 degrees, and they're both the same size. They're X and X. So, let me smart here. I'm going to go back to this guy, text box. Okay. 110 divided by 2 of them makes each of them 55. Okay, I'm going to go label that real quick. Those little blue guys are both 55. He's a 55 degree arc, and he's a 55 degree arc. Now, this guy here is a central angle. He's equal to his arc. So my answer is also 55 degrees. There are a couple other ways we could have gone about doing this problem since they had the parallel lines. But I sat here and I thought, why? I mean, this part here is 55, so that makes that angle that's up there going to be 55 because they're both X. And since that arc is the same as the central angle, then boom, there we go. So I think we're good on that. Okay, let's move to number 5. RST are all in a straight line. RS and ST are both 12. And the area of the whole triangle is 48. How long is the altitude? Okay, so they talked about area of a triangle. So that's where I'm going to start with. Area of a triangle is half base times height. The area of this triangle, they say, is 48 equals a half times the base. The base is the bottom down there. 12 and 12 make 24 times the height. So I have 48 times half times 24 times the height. So 48 equals a half times 24 is 12 times the height. Solve for H. H is 48 divided by 12 is 4. So my answer is 4. It's a pretty nice, easy answer. All right, number 6. Ooh, this guy looks hard. Another trapezoid, because he's got 4 sides and they kind of got the slanty one and got 2 parallel. The perimeter that's all around it, at all the outside, is 45. BC over there is 9, and AD over there is 6. He says find the area. Okay. So now I'm going to do some thinking. The perimeter, that's all the sides added together, is 45. And I already know one side is 9 and one side is 6. And that leaves me 30. 45 minus 9 and 6 makes 30 for the two bases. Now I'm going to think for a second. It says it wants the area of a trapezoid. Area of my trapezoid is the height over 2. And then it's my two bases. Base 1 plus base 2. Okay? We had that formula earlier. So my area, that's what I'm looking for, is my height. My height is 6. So 6 over 2. And then my bases added together. I just figured out the bases added together was the leftover 30 up here. So times 30. And that is 6 divided by 2 is 3. 3 times 30 is 90. The answer is 90. That's the area of the trapezoid. Okay, we're moving on along. Now we're at number 7. The figure below is a circle inscribed inside of a square. And the area of the shaded region is what? That's what we're trying to find out. So here's what I do now. The shaded part is basically the square minus the circle. That's basically what I know. If I take the square, take away the circle, I'm left with all the shaded parts. That's what I know. So, and this is area. So I'm going to put these together. Area of a square. Area of a square is the two sides multiplied together. Side squared. So side squared minus the area of the circle. The formula for area of a circle is pi r squared. These are things that I know. Now I'm going to grab some numbers. It says it wants to know the area. Now the side of the square is 18. So 18 squared minus pi. We'll go back up there and I'm going to grab pi. And then the radius of the circle. If the whole way across is 18, half of that would be the radius, which is 9. So we'll put 9 squared. Okay. Now I'm going to just figure out what that is. I'm not even going to type that. That's, why bother? Okay, undo that. Okay. Oh, I guess I'm going to have to put him back. That was not what I wanted to do. So undo that. Oh, that was not what I want to do either. I'm going to type it again. Sorry, guys. Me and my having fun with the... Should have just typed it all to begin with. Instead of saying, I'm just going to be easier on y'all, and not really being easier because I'm just talking to myself. R9 and then squared. Okay. Back to where we were earlier. Okay. 18 times 18, if you put them in the calculator, is 324. Minus 9 times 9 is 81, so my answer matches D. That's what I was saying. Why type it in on the computer, and I just took longer typing it twice. So the area of the square minus the area of the circle. All right, number 8, the length of the diagonal of a 21 by 28 rectangle. All right, let's go figure out what that is. I'm going to draw me a rectangle. Remember, the diagonal goes across cross from side to side. And this one's 21, and that's 28. And if I could actually draw a rectangle, you know this is a right angle. And so I could use Pythagorean theorem. And that's what I'm going to do. I am so tired of seeing this thing in my face. There. So a squared, 21 squared, plus b squared, that's 28 squared, equals the hypotenuse c squared. And then I'm going to add those together. So, oops. 21 times 21 is 441. 28 times 28 is 784. That equals c squared. Okay, now I'm going to get me another one. 441 and 784, that's 5, 2, so 1225 equals c squared. And then I take the square root of that. All right, so I'm going to take the square root of 1225, and I get c is 35. That's the hypotenuse there, or the length of the diagonal, which is 35, which is E. Just the Pythagorean theorem. All right, number 9. Ooh, he's the same kind of problem. He says, we've got the circle inscribed in the square. What's the area of the shaded region? Same thing, square minus circle. And I'm not going to type all that formula and stuff again. I'm going to go straight over here and do the work. Area is, now remember that's the square, which is 14 on the side. So 14 squared minus, now we got to do the circle, pi r, half of 14, that's the radius, would be 7 squared. And then we go to our calculator. 14 times 14 is 196. 196 minus 7 times 7 is 49. So 196 minus 49 pi. There he is, number part A. All right, now we're in our last question. We made it through, guys. In the circle below, the radius is 10, and we want to know the length of AB, the arc. You guys, again, this is like the area of a sector. Since I've had trig, I have a different formula I use. I use S equals R theta. So what you guys use for arc length is S equals, remember I did that N earlier with the pi. So I'm going to put the pi on him. All right, over, now there's 360 degrees in our circle. Actually, I'm going to put him over 180. And call that R. My formula is S equals R theta. All of this here is the theta I was using before. But I'm going to explain it to you. So grab me an equation again. S is arc length. We don't know what that is. N is your central angle. Remember, and that's 45 degrees. So I've got 45 times pi. I'm going to go get me a pi symbol. And then I'm going to close that up a little bit. Divided by 180 times the radius of the circle, which is 10. All right. So 45 divided by 180 times 10. So 45 times 10 divided by 180 is going to be 5. So in this case, my answer is 5 times the pi. I just leave everything out except for the pi. I put everything in the calculator but the pi sign. So I take 45 times 10 and divide it by 180. And I get 5 times pi. So my answer is B, 5 pi. All right. Now, what did I just go through? I went through the entire SB 13 packet. You have a quiz over SB 13 on Friday. It's going to be about 10 questions. You can pause this video, go back, do whatever you need to with the video, and ask questions if you need to. Definitely read through all of this stuff because it's been a long time since a lot of you have had geometry. So I wish you luck on this. And if you need some help from me, you know you can always ask.